G'day. Today we're going to do some proofs using some properties of triangles and circles and so on. So the first question we're going to go is, okay, we've got a rhombus which is A, B, C, D. M is the midpoint on AD such that CM bisects the angle DCA. Right, show that the angle DCM is 3 times larger than the angle ACM. So what we're looking at doing there is showing this angle here is 3 times that angle there, so that makes that 3 dots. That's what we have to show. Alright, so there's lots of ways of doing this, and there's no particular right way or wrong way. The main thing is just to show your thinking and your logic, alright, when you're doing things. The first thing I'm going to do is I'm going to extend that line there. Alright, because it's a rhombus, we know that these lines here are parallel to each other. And we know these two lines here are parallel to each other. Alright, so we can use that concept. Now, the thing about a rhombus, when we start thinking about a rhombus, is that we know with a rhombus that alternative sides, right? Let me go up a bit, sorry. This angle here and that angle there are the same, and these angles here have to be the same as well. Alright, so those angles are the same, and those two angles are the same. Now we know they're equal to 360, so we know that these have to be complementary angles, have to add up to 180 degrees, don't they? Because if we extend that angle there, then that's got to be x, doesn't it? Oh, so that's the thinking I'm going to use with this one here to try and prove what we're trying to do here. So if I know that these two angles are 2 dots, that's a bisector of that, isn't it? Okay. So I know this whole angle here is equal to 4 dots, which means this whole angle here has to be equal to 4 dots. Which means, because these are parallel lines, means that this angle here has to be 4 dots, doesn't it? So this angle here has to be 180, take 4 dots, and so therefore we know that this angle plus that angle plus that angle has to be equal to 180 degrees. We can work out what M is equal to. That's my thinking. Now it's what we have to do is put it down on paper. So we'd say lines AD and is parallel to BC, and we know that DC is parallel to AB. So we're just establishing the fact that we actually know those things are parallel. We know that angle A or D, AB has to be equal to 4 dots. Right? So therefore angle, we'll put a N up here, therefore angle NDC has to be equal to 4, right? And they are what we call allied angles, aren't they? What's the special name for those? I think they're allied angles. Right, so we know there, therefore we know that angle MDC is equal to 180, take 4 dots. Right, we know that 180, take 4 dots, plus 1 dot, plus, and we'll call this one here x, plus x has to be equal 180 degrees. So I'm going to cross that off over there. So therefore, we've got minus 4 dots plus that, so it's minus 3 dots plus x is equal to 0. So therefore x is equal to 3 dots. Alright, so therefore, go back up here. Therefore, QED, we've proved that angle, is it? DMC is equal to 3 times the angle ACM. Alright, so that's the sort of proofy thing that you'd need to do for that. Alright, let's go down to number 2, have a go at doing that. So we've got a rhombus. Alright, so the rhombus part here is in fact this part of the actual shape. Important that you picture that. So what is a rhombus? A rhombus is really a square that's been pushed over. So if we know that, we know that length there, that length there, and that length there are all the same, aren't they? Alright, so we know that's the case. Alright. The other thing is we know that this angle here and that angle there are the same. We know that angle there and that angle there are the same. Right, so that's the thing that we do know. And then what we're doing is extending E out to there. So we have to try and prove that this shape is a parallelogram. Now parallelogram only has one pair of parallel lines. So we have to prove that the line DC and the line ABE are in fact parallel. That's what we have to try and prove with that. Alright, so I suggest when you're doing these sort of things, have a big diagram, I suppose, with that. Right, even though it's a parallelogram, we know that those two sides are the same, and that's the length there. Right, we're going to call this, say, that angle there theta. That means that this angle up here is going to be theta. We can call this angle here, say, phi, there, and call this one here alpha. That means that when we're doing this over here, because they're parallelograms, right, we know we've got a diagram here. We know that these two things have to be, we've got a congruent line there. So these two things have a common side. So what we're saying is this triangle here, ADB, right, and CDB are in fact congruent triangles because they have all equal sides. Right, so we can say triangle ADB and triangle BDC are congruent, and that's to do with side, side, side. We've got 3 sides the same length, so therefore that means that we have to have 3 angles that are also the same in there, don't they? Alright, so if that's the case, then this has to be called phi and that has to be called alpha. Alright, now the one thing that we do know is theta plus phi plus alpha has to be equal to 180 degrees, doesn't it? Now we also know that the interior angles are there, right? Those interior angles have to be the same as well. So we know that angle DBE has to be equal to theta plus phi. So therefore, and that we know it's the external angle equal sum of interior angles, right? So that's the case, which means therefore that angle CBE has to be equal to theta. Alright, so therefore that's the case. It has to be equal to theta. And since angle DCB equals angle EBC, therefore we have allied angles, or alternate angles. And this means that DC has to be parallel to AE. Therefore, parallelogram. So that's a parallelogram. Alright? So that's the sort of logic that you need to show with that. Now the third one we're going to go look at is here. We've got triangle ABC is an isosceles triangle such that we know that this side here, AB, is the same as this side over here, AC. So we know they are same lengths. Now if we know that, then we know that that angle and that angle must be also the same. Agreed? Now we know that we've drawn DE, so it's perpendicular to BC, so it's making a right angle, and AC, AB, producing up at F. Alright, so prove that the triangles AEF, that's what we're trying to prove, is this triangle here, AEF, is in fact an isosceles triangle. That's what we're trying to prove. Right, so this again comes down to our logic, and it's important to get your logic first before you start writing it down. Let's say we know that angle there is alpha, right, and we know those two lengths are the same. Then if we called this thing here theta, then we'd know that angle there is theta, wouldn't we? Does that make sense? Because that's because that's vertically opposite. And if we've got alpha, we know that it has to be theta because there's 180 degrees in a triangle. Those two angles are the same, then these two sides must be the same. It must be an isosceles triangle. Alright, so that's our thinking. Alright, so we say so we know AB equals AC, and we can say that was given to us. Letting the angle ABC equal the angle ACB, which is equal to alpha. So we're just saying let that be the case. Let angle DEB be called theta, and so therefore angle DFC equals theta, because we know that alpha plus theta has to be equal to 90 degrees. Right. We know that angle FEA has to be equal to theta, because that's vertically opposite. To angle DEB, and so therefore FA has to be equal to AE, and what are we saying? And triangle AFE is isosceles. Right, so that's the sort of idea about your thinking. So my suggestion with this process when you're doing these particular proofs is to think about your logic before you start writing it down. Go through and solve it, and then actually write down the bits that prove. Now, I've heard in a video, I think the video said something like this. Getting your answer might get you the C, but to get an A with this stuff, you have to actually show your thinking and your processes behind. Now, keeping in mind, I'll give all that information on a sheet for you. That shouldn't be quite as hard to remember what you've got to do. Alright, so some of these can get a bit tricky, but I think most of them are fairly straightforward. Alright, so we'll be working through these in class together and also with you working on them as well.